Alright, so I see that I want to find this derivative, which is going to be using the quotient rule, which the quotient rule says leave the bottom alone, time the derivative of the top. Now the top is the chain rule, where you do that whole deal where you say y equals u to the 6, and then of course u is what's inside the parentheses. I take the derivative, which would be 6u to the 5th, and this derivative would just be 8. I multiply the two, and then finally I substitute u back in. So all this over here was the chain rule piece. So that's just taking the derivative of the top. So, I forgot my 5. So that's going to get plugged in here. So I'm going to have 48 8t minus 3 to the 5th minus, leave the top alone, 8t minus 3 to the 6th times the derivative of the bottom, which would just be 1, because the derivative of t would be 1, and then you square the bottom. Alright, so what can I do with this? Well, I could distribute this 48. So I would end up with 48t, 48 times 5, 240, and then 8t minus 3 to the 5th, minus 8t minus 3 to the 6th, all over t plus 5 squared. Now I just see that I could factor out an 8t to the 5th. So 8t minus 3, I should say, to the 5th. So that all got factored out, so the only thing left is this piece, which is 48t plus 240. Notice what happens over here. If I factored out 5 of them, there's only 1 left. And then I could distribute this negative sign. So I'd have a minus 8t, and then a negative and a negative 3, a plus 3, all over t plus 5 squared. And now all I'm going to do is I'm going to collect some like terms. So I still have my 8t minus 3 to the 5th. 48t minus 8t is going to be 40t. And then 240 plus 3 is going to be 243, and it's still all going to be over t plus 5 squared. And that is my final answer.